Today, we're very pleased to have with us all the way from Germany, Simon Merkt-Schippers, and we'll be sharing a little bit more about him in just a moment here. But this is the third part of our series. And today, those of us who are on the call, you're going to be hearing about, quite literally, the most advanced metal additive manufacturing on the planet. And it's a distinct pleasure to be able to showcase this here at PNAA's webinar and have Simon, who's an expert on their new NXG 12600 machine, join us today. And I won't steal too much of his thunder because it's just an amazing piece of technology he'll be sharing with us on. So thanks for joining us today. For those that are PNAA members, we will have this in our member portal also. And I know there's a lot of different activities going on today. If you know someone in the industry that you think may enjoy this or a PNAA member, make sure to tell them that that will be there pending approval of SLM. We need to make sure that that's okay with them. But we're very excited. And if we don't have the recording, you can share with them, of course, what you learned today. We'd like to take a minute to thank all of our corporate circle sponsors. So these are the different companies that help support PNAA financially, of course, during this time. More important than ever. And without these corporate circle sponsors, we wouldn't be able to create all the awesome programming like what you'll see today and what you'll be hearing about at the end of the event today. So I'd like to take a moment to thank Boeing, Snohomish County, Payne Field, Moss Adams, ProShop, Sekisui Aerospace, Orion, Deal Aviation, Cyberstreams, Impact Washington, Northwest Aerospace News Magazine, AJAC, CG Tech Bearcut, and Baker Hosteller. Also, if you have not been to one of these webinars this year, this is our 20th anniversary. We're so excited to be the organization that's been around helping increase the competitiveness of aerospace manufacturing here in the Pacific Northwest. And thanks to everyone that's here on the call today. Of course, this is a membership-based organization. It's really all about the people. That's what PNAA is about, is bringing these different people, the different aerospace companies together. So thank you all for being a part of that and helping us achieve our mission for 20 years now. We have got upcoming events, and this time of year, we've got some really fun and really exciting stuff coming up. This Friday, if you or your companies aren't aware, this is going to be our 8th annual Women in Aerospace Conference. This is it's more than a half-day event. We're going to have keynote speakers from all different types of companies: Alaska Airlines, Boeing, Collins Aerospace, Orion, just to name a few. A lot of stories of inspiration. It's really talking about women in the industry, both past, present, and the future. And one of the things we're going to be doing is a hackathon, going into small groups and creating the solutions to real-world challenges that we have in the workplace right now. It's going to be a very productive and fun and inspiring event. And once again, thank you to all of our sponsors down below for helping make this event possible. That's Friday, May 21st. You can learn more on our website, pnaa.net. And then next week on the 25th, we're going to be having our webinar. It's called Your Company's Next Big Move. And we're going to be really talking about what happens to your company, when it's time for a transition, and what do you do, and some stories about how companies have done that and the things that you need to do to prepare for those transitions. So we're very excited about that. That'll be at 12 p.m. next Tuesday. And then on Friday, up there in Snohomish County, hey, Terry, we are going to do a Factory Friday tour of Electro Impact there at Harbor Point in the Mukilteo area. And we're going to be talking specifically about the new tools and processes that they've been putting in place to increase their quality, and probably some inspiring stories there that you can take back to your companies and look at ways to implement maybe some similar things. So join us Friday at 12 p.m. on the 28th. More information, of course, on our website. And then we go into some more larger events. Our 9th annual Aerospace Defense Conference. This is June 10th. This will be a virtual event. We're going to be joined by NASA, and we're going to have a B2B fair with NASA primes, companies like Jacobs and Teledyne, SAIC, too many acronyms, and JPL, a few other companies, Boeing, will all be there. So this is not only a great time to learn about what's happening in the defense industry in the year to come and learn how to land government contracts if you've not done that, but then you'll have the opportunity to meet face-to-face with some of those companies looking to place new direct business. So June 10th, that's an all-day virtual event. Following that, June 22nd, we're launching our second annual Cybersecurity Symposium. This is going to be our first in-person event. We're going to be at the Nexus Hotel in Seattle, and we're going to have some top industry folks speaking there. The list is just starting right now. We've got Cyberstreams confirmed. They do a lot of IT support for the aerospace industry here in the Northwest. We're working on some other really amazing speakers. Stay tuned and check our website out for more details on that. And then finally, July 13th, this is going to be our first annual aerospace technical conference. And we're going to be diving deep into both some of the foundational technical aspects, maybe metallurgy or machine setup, things along those lines, as well as some of the leading technology that will propel manufacturing into the future. So stay tuned for more details on that. This is also going to be an in-person event, and that's going to be July 13th. So now it's my pleasure to introduce Simon Merkt-Schippers. Simon has joined us this evening from Northern Germany. Simon is the head of product management, and I think wears a couple hats over there at SLM. And today he's going to be talking about their new flagship NXG 12600. Simon, I can't hold myself. It's a 12 laser, 1,000-watt machine that has 12 1,000-watt lasers producing additive parts, and he's going to tell us all about it today. So Simon, thank you so much for joining us all the way from Germany. It's a pleasure to have you here, and I'm going to go ahead and turn it over to you.
Thank you very much, Brian. I'm very happy to hold that webinar to speak about our flagship. And yeah, let me share my presentation that I have prepared for today. And yeah, let's speak about our latest machine. You can see the slides.
Yes, we can. And just as a reminder, everyone, Simon is a wealth of information, and you're going to be seeing stuff you've literally never seen before. As you've got questions, big or small, simple or complex, if you would type those in the chat window, and then I'd be happy to moderate and ask those questions of Simon as we go through the presentation. All right, Simon, thanks.
Thank you, Brian. Yeah, so I'm really happy to talk about the NXG 12600 machine. It's a true game changer for the metal additive manufacturing industry. It's a machine that we have launched last November to the world, and it's a very special machine, and that's something you will find out during my presentation. Would like to start with a little video of the machine, and it's a video that we have shown during the launch event that we did in November to present the world our new flagship. So please enjoy. All right, before we jump into the details of that machine, I would like to shortly introduce you to SLM Solutions. Yeah, SLM Solutions, we are one of the leading metal AM machine manufacturers, providing machines for selective laser melting technology. We have like 650 machines installed globally, serving a broad range of blue chip customers from various industries. From aerospace industries, we have customers like Rolls-Royce, Safran, Honeywell, UTC, Collins in our customer base, and we are very proud of this. Some facts and figures about SLM Solutions. We are we're the co-inventors of SLM technology in the late 1990s. So we have a technology heritage of more than 20 years. We spend a lot of revenue we spend a lot of our revenue into R&D to keep our technology leadership for these technologies. We have filed a lot of publications and granted a lot of patents in the last 20 years to secure our technology leadership here. Some recent results. So we were growing 26% last year in a rather flat metal additive manufacturing market. So we are very proud about these results. If you have a look on the installed base of our machines, we have around 50% of our installed base are multi-laser machines. So machines equipped with more than one laser. And actually in our order backlog, we have 90% of the order backlog are machines with multi-lasers. Yeah, this is our current product portfolio that we offer to the market. It's actually, and it is an evolution from 2009 to now. So we have the SLM 280. It's a mid-size machine in our portfolio. It is in 2009 we brought this machine to the market as a single laser machine. Then in 2011 we upgraded that machine with a twin configuration so the machine has two lasers, is equipped with two lasers. Then we brought the SLM 500, a machine with a larger chamber size, to the market in 2013, equipped with up to 4 lasers working in parallel. And then we brought in 2017 the SLM 800, equipped with a large Z axis to even print larger parts. And our recent addition to our product portfolio is the NXG 12600, equipped with 12 lasers. So it's a really large steps towards more productivity, higher productivity, but also towards larger build envelopes, as this machine is featuring a build envelope of 600 millimeters cube.
And Simon, for us over here on this side of the pond, that's about 2 feet cubed. Does that sound about right?
600 millimeters is about 2 feet. Yeah, 2 feet.
Cool. That's a pretty big size. That's a pretty good size 3D printed part.
Yeah, it's like it's like an oven. Yeah, an oven where you in your kitchen. It's like the size of a big oven. Right. Actually, so you can fit quite large parts into that machine, right?
Got it.
And it's also one of the biggest machines in the world regarding the build envelope.
Right. And I don't know if this is the time or if it will come up later, but will you be sharing pricing information on this?
I will not share pricing information because with this machine, we rather speak about cost per part. So we rather speak about the concrete applications that our customers want to print, and about the costs these parts will have, because usually this machine has great benefits on cost per part for almost every application out there. So we rather talk about this, but I can give you some numbers. So our smallest machines, they start at around $300,000 US, and then our NXG 12600 machine is around $3 to $4 million US invest.
And we were talking before the webinar started. It sounds like it's quite safe to say that this is the most advanced metal additive manufacturing machine in the world.
It is indeed. It is indeed. So currently, most of the machines in the market are equipped with 2 lasers, sometimes 4 lasers. There are some announcements from other machine OEMs to go for, let's say, 8 lasers. But there's really no machine that is currently existing on the planet and ready to be sold, equipped with 12 lasers. So it's really a very unique machine we are talking about here.
And I'm going to guess today you're going to tell us the importance of having more lasers in the machine.
Exactly. That's what I will refer to in a couple of minutes. But yeah, 12 lasers mean a lot of productivity increase, up to 500% compared to our SLM 500, which is already equipped with 4 lasers. So, but I will come to that in a minute, Brian. Yeah.
Okay, Simon, we got another question. Are there plans for machines in the future that would have a larger build envelope?
Yes, we do have plans. It's not that easy to scale up the build envelope, as you need to guarantee a clean atmosphere, a good gas flow, and so it's not very easy to scale up the build envelope. But for sure we have plans to go even bigger. But for now, let's say it's I think it's already an impressive size.
Oh, yes. No question. Great, thank you.
Cool. Yeah, let's talk about a bit more on the details of this machine. So it's 20 times faster than a standard single laser machine. It's 5 times faster than an SLM quad laser machine, which is what was already, before we launched the machine, the most productive machine in the world. It's designed for serial production and optimized for large parts and high volume production. Each of the lasers have 1 kilowatt, so this is giving you a lot of opportunities to increase productivity, working with higher scan speeds. So again, typical machines out in the market are equipped usually with 400, 500 or 700 watt lasers. Here we equip the machine with 1 kilowatt and to get even more productivity out of the machine. There's also a new function that we introduced as a zoom function. So we have a variable spot size on this machine. So we can vary the spot size on the fly, allowing you again to increase productivity of the process. So it's really a machine designed for serial production, and definitely the most productive machine in the market you can find. Yeah, this also shows this slide here. We have compared our machines with our competitor machines. You can see that here on the left side. So our competitors' machines in terms of build rate are typically below the 150 cubic centimeters per hour. Our existing machines, the 500 and 800, equipped with a quad laser configuration, can deliver already quite high build rates of more than 150 cubic centimeters per hour. But if you look on the right side, the NXG-12-600 is just providing a massive increase of productivity of 500% to the latest state-of-the-art machines, which is quite impressive. Yeah, and now I would like to talk about a few applications and give some application examples of the NXG-12-600 machine. So this is a engine midframe that we have produced already last year on the machine. So you see here the substrate plate of this machine, so the 600 times 600 millimeter size. You see the component that we manufactured and some tensile specimens to prove the quality of the build afterwards. And yeah, some facts and figures about this application. So this application was made from Inconel 718 material, so a nickel-based super alloy that we can process perfectly in this machine. It has large dimensions, so it almost fills our complete build envelope. And we were able to produce this part in less than 70 hours, which is already quite a good result. We had a build-up rate of 207 cubic centimeters per hour in this case. We were not using the full laser power. We were only using a 350 watt parameter set. So we expect to have much larger build-up rates, at least a factor of 2, if we use high power parameters like 750 watt or up to 1000 watts. So yeah, this is quite a nice example also from aerospace industry, and yeah, we hope to get more kind of these applications from our potential customers.
Hey, Simon, can you go back one slide?
Sure.
Can we kind of geek out and talk a little technical talk for a moment? Are you okay with that?
Sure.
So for those that may not know this, either on our webinar today or watching this video later in the future, Inconel is a really challenging part to machine. And Simon, is that a fair assessment?
Yes, it is. It is processing it with conventional technologies like machining. It creates a lot of wear on the tools, so it's really hard to process conventionally. Here with our technologies, the SLM technology, laser powder bed fusion technology, yeah, we can easily weld it together as you see in this part. So having almost no scrap, we can recycle the powder which is not molten. We can reuse it for the next process. So Inconel and nickel-based alloys are a super material for our technology, and it has a lot of advantages to process this material with our technology compared to conventional technologies like machining.
Yeah, you know, I can't give on the spot quote for what this part would cost if you could manufacture it conventionally, which you can't, which I'll speak about in a moment. But we're talking an extremely expensive part. I couldn't even begin to guess tens or hundreds of or thousands of dollars, if not more. But the other thing that you see here, and correct me if I'm wrong, Simon, is you see the passages, kind of those rounded curvatures along the side there. These are hollow tubes. Simon, correct me if I'm wrong, but there's probably no way that a conventional subtractive or like a mill could actually make some of the features on this part. Is that correct as well?
Exactly. You can integrate functions that were not possible to manufacture before. Yeah, that's absolutely correct. So we produce this part openly, so you can see the inside complexity of this part. So it would be a very great challenge to use conventional technologies to produce that part. Yeah, so that's correct. And with our technology is quite easy to manufacture it in the way you see it in front of you.
Yeah. So yeah, a couple of big takeaways. And Simon, I hope you don't mind me jumping in. I think this is really important. With this technology, you're able to create a part that you physically couldn't create on a standard mill. Secondly, you've got next to no scrap rate, which is saving the manufacturer money and ultimately the end customer. And then as far as the complexity and the speed to build this, it sounds like you have some advantage there as well. So very
exactly.
impressive.
Yeah, exactly. Lead time advantage. We can do functional integration, so we can combine multiple parts in one part, producing it with our technology. So there are massive advantages for these kind of parts to go additive. Yeah.
Thanks.
Okay. Yeah, then I would like to show you another example that we have produced on our machine. It's a part from Porsche. It's an engine housing for an electric car. It's a part we produced from ALSI 10mg, so an aluminum alloy. And this part was produced with a high power parameter of 900 watt. And we could build this part in just 21 hours, which is really fast for our technology. This part was redesigned together with Porsche, and we were able to get a weight reduction of 10%. We were able to integrate cooling channels to improve the functionality of the part. The stiffness between the electric motor and the gearbox was increased by 100%. due to the lattice structures that we have integrated into the part that you can only do with our technology. Here you see it, the lattice structures here on in this section. And then all in all, we have actually reduced the assemble work by around 40 working steps in producing a functional integrated part in one step. So that's a really cool example, and we are really proud to cooperate here with Porsche on our NXT 12600 machine. Yeah, and then the third example I would like to show is a 4-cylinder head that we have printed. Here you see some results as it was printed on our SLM 500 quad laser system with 700 watt technology and 90 micrometer layer thickness. So here we were able to produce one 4-cylinder head in our machine in just 27 hours, which was already quite fast. But if we now have a look and produce this part on our NXT 12600 machine, we could even print 3 parts at the same time in one job. And if we use the full power of 12 times 100 watts, we can produce 3 parts almost in the same time as we're able to produce 1 part on the SLM 500, resulting in a build-up rate of 630 cubic centimeters per hour, which is very, very fast. All right, that's the update regarding applications I wanted to give you. Now let's talk about a few more key features of our machine. So we have spoken about the lasers. We have spoken about the variable spot size that we can change on the fly. Let's rather talk about some other features that we have into our machine. So we can actually preheat the substrate plate of the build envelope to 200-degree preheating. So this helps to process parts with less internal stresses. We can have a very low ppm O2 atmosphere in the machine that guarantees homogeneous part properties, even when we process reactive materials like titanium or aluminum in the machine. We always have an open architecture, so our customers are able to manipulate parameters, fine-tune parameters on their specific application to get the maximum out of this machine and create competitive advantages for their specific application. For sure, we also invest a lot into safety. So safety in terms of machine and operator safety. So we have a closed loop powder handling so that the operators of this machine have no direct contact to the powder, which is a dangerous good to deal with. So there are many features that we have in this machine that delivers high productivity, quality, safety, and open architecture. Yeah, I think we have already talked about that mainly. So the build envelope is 600 cube millimeters, resulting in a build volume of 260 liters of powders. So it's quite impressive. And yeah, you can produce one large part on this machine, or you can produce a huge quantity of smaller parts at the same time on this machine, as shown with the engine housing, where we have produced 3 parts at the same time in one build job.
Hey, Simon, there was a question a little bit about the transmission coupling piece that you had some slides ago. No need to go back there. But somebody was asking if that was a forged piece, and the answer is no, that was one big additive printed housing, correct?
Let me go back. So was it about, that's the Porsche part? So that's the electric housing. So that is a part that is owned by Porsche that we printed. Mm-hmm. And this is just a 4-cylinder head that's not related to Porsche.
Sure.
it's a generic part that we were using here to show how productive our machine can be.
Okay. Yeah, and I think you mentioned, it's something for the audience if they weren't aware of this already, like that transmission housing there, or that assembly. I think you mentioned that you reduce the assembly time, and I think that's one of the big takeaways here is you could have a large assembly where normally you're coupling different parts or assemblies together because that's as big as you can make them, or they're coming out of the casting. With this technology, you could actually integrate all those into one large part, as long as you can get in there to do what you need to do, right?
Exactly, and that's a massive advantage. And for this, you need to know how to design for AM, yeah, to make it a functionally integrated part.
Mm-hmm.
For this, we have trainings in our portfolio to teach our customers how to deal with design for AM. We also have very experienced application engineers that can support customers and redesigning a part for our technology, to profit from exactly this capabilities. Yeah.
Okay, we got another question that came in. What applications in aerospace manufacturing are you targeting? Lighter weight aluminum parts versus lighter weight carbon fiber? I suppose they both have their place in planes. How do you compare the two options for an aerospace engineer?
So let's say we are not dealing with carbon fiber applications. So with our machines, you can process just one material, let's say. So no carbon fibers that we can integrate here with our technology.
Mm-hmm.
So with this machine, we are targeting for sure the space industry. So space nozzles, combustion chambers, so all this kind of stuff. From the space industry, we are also targeting automotive parts like the electric engine housing you see here. So we are targeting in automotive also other chassis parts and stuff like this. So there's a lot of applications that perfectly fit the NXG 12600 from various industries, but the main focus we are currently having with this machine is definitely automotive, space, and civil aviation.
Okay, great, thank you.
All right. Yeah, let's continue. I mentioned the zoom function. So this is the first machine that can on the fly change the laser diameter. So typically machines cannot do that. So you have to stick to one laser beam diameter of, let's say, 80 microns, for example, and you have to run this diameter across the whole build. Our new optical setup that we have developed allows us to change the diameter on the fly. So this again gives more options to increase the productivity of the process, as we can produce bulky parts of the geometry with a larger beam diameter. So we can increase the melt rate there a lot. So again, a big opportunity to increase the productivity and also the throughput of our machine.
And Simon, what would be the say the drawback to going to a wider beam versus the more narrow beam?
Yeah, sure. A wider beam, it's not possible to manufacture filigree parts, let's say, and also a wider beam might result in a slightly worse surface roughness of the parts. So typically, you use a wider beam more in the inside of the parts, and you melt the contour and the outer shape of the parts. You rather melt with a small beam diameter, where you need the accuracy and then the good surface quality.
Okay, great, thanks.
Yeah, in terms of software, our machines always comes with a software for data preparation, but also for quality control. So our machines are equipped with a lot of sensors to monitor all process critical, let's say, parameters like oxygen level inside the machines. So we can track all this, and we can also visualize this in our additive quality software, sorry. We have an LCS, a layer control system. That's actually a camera that sits in our machine that is taking pictures from the various layers that are deposited. And this system controls the quality of these layers. So was the layer completely deposited? Are there any defects in the recoder medium that might result in a layer that is not homogeneously spread over the build envelope? So all this can be detected by our layer control system. Then we have a melt pool monitoring option. So there we monitor the melt pool of the part that we produce. We detect the signals that come from the melt pool, and we can clearly detect where we have a solid melt pool. We can also detect overheated melt pools. We can detect lack of fusion. So if, for example, the laser was not melting a certain area of the part, so the system could detect that. So it's quite a cool feature for our machines in terms of yeah, let's say quality control. And then the last feature that we have to qualify and control the key process parameters is the laser power measurement. So we have a laser power measurement. So the system is actually measuring the emitted laser power from all the lasers that we have integrated in the machine, and yeah, measures the laser power and ensures that we work with a homogeneous laser power across the whole build job with all the lasers that we have equipped in the machine.
Hey, Simon, speaking of laser power, can this machine process titanium as a material?
Yes, for sure. It can. Definitely, it can process non-reactive, reactive materials. It can actually process all materials which have a certain degree of weldability. Yeah, so we can process stainless steels, copper alloys, nickel-based alloys, titanium alloys, aluminum alloys. So it's quite a broad range of materials that we can process in this machine.
It sounds like basically any type of metal that would be used in an aerospace application.
Yeah, basically everything. For sure, there are some more exotic materials like titanium aluminide, for example, which is not easy to weld. We are also working on that, yeah, but we can cover most of the common materials from aerospace industry. That's correct, Brian.
Great, thanks.
Yeah, actually here there are a few materials that I mentioned here, and actually we are qualifying the materials and parameters with partners actually also in the US. Yeah, partners like NASA or some leading universities in the US that help us qualifying our materials and parameters for our machines. So ranging from titanium 6.4 over a F357 aluminum material to nickel-based alloys like the 718, and also stainless steels, tool steels, Hastelloy X. So here we work with leading research facilities and also leading facilities to qualify our parameters and materials to make sure that they match the industry standards that are listed here on the left side. Yeah, and then like my last slides for today, actually some voice of the customers about the NXG12600 machine. Yeah, because we just started selling this machine, but we have a tremendous feedback on this machine. So we have every week we have multiple customer visits here also on site, even though COVID-19 is still going on. Yeah, and I would like here now to present you some voice of the customers from some of our customers. So the first voice of the customer I would like to present you is from Porsche. So you saw already the engine housing, and unfortunately the video is on German, but there is an English subtitle, so so you can follow the video.
Die additive Fertigung, jetzt bezogen auf Porsche, bietet natürlich extrem interessante Anwendungsmöglichkeiten. Was wir jetzt gemacht haben, ist natürlich so einen kleinen Proof of Concept mal unser Bauteil zu benchmarken. Also ich war überrascht, wie schnell die Rückmeldung kam, dass der Baujob fertig ist, weil wir aus der Vergangenheit ja schon andere Zeiten einfach gewohnt sind. Also wir hätten da noch ein paar Ideen, wie man das noch erweitern könnte, das Gehäuse. Ja, wir sehen, wir können damit 40 Arbeitsschritte einsparen. So, und dann kann ich mir vielleicht, ist das Bauteil halt teurer als ein klassisches Gussbauteil. Dafür kann ich vielleicht meine Qualität erhöhen, weil ich Teile nicht mehr anschrauben muss, weil ich Dichtflächen nicht mehr habe und so weiter. Und ist auch nicht so einfach, so eine Gesamtkostenbewertung dann zu machen, aber ich glaube, genau da muss man drauf schauen, als immer nur die Bauteile irgendwie zu vergleichen mit einem Gussbauteil oder mit einem Schmiedebauteil. Das ist, wird der Technologie nicht gerecht. Ja. Die hat viel mehr Potenzial. Und jetzt bin ich mal gespannt, was sich da zukünftig noch ergibt mit SLM zusammen.
So again, we are very proud to work with this leading automotive OEM here in Germany. Yeah, it's just great, and I think they will profit a lot from our technology in the coming years.
Simon, we've got another question that came up. Since the layers are sort of rolled out before the sintering process, is it possible to layer with one metal and another layer with a different metal, creating a welded bond between the two layers?
So actually, if I got it right, the question is regarding a two material process, and actually we are currently developing an upgrade kit for our existing machines to go for two material process. So yes, it's possible. We have already proven the capability to process two materials in one process. For example, combining steel and copper in one part. So yeah, if you like, I can try. Actually, I can try to. If I have that in the backup of my presentation. Here you go. Can you see that, Brian?
Yes.
So this is a technology demonstrator that's was not built on the NXG12600 machine, but it was built on a 280 machine. And yeah, this as you see here, we were able to combine a copper alloy, copper zirconium alloy with this steel, and we believe there are applications mainly in the space industry for combining these two materials, for example. So yeah, the answer is yes. So we have developed a process for this, but to be fair, on a smaller scale for now.
very interesting. That's pretty incredible.
It is. I was very pleased to see this coming out of our engineering group and our NTI group. So it's really amazing to see the first parts combining two materials. Yeah. Yeah, another voice of the customer comes from one of our Italian customers, 3DNA. So they are one of the leading service bureaus for metal AM in southern Italy. And yeah, let's also listen to 3DNA here, what they say about NXG 12600.
I do believe that with AM, 3DNA will manage to give an exhaustive answer to the production needs of aerospace, automotive, and energy markets. This, in brief, means higher productivity, cost per part reduction, and shorter lead times. SLM 600 next generation machine is definitely raising the bar in terms of productivity and cost per part reduction. 3DNA is confident in next years to conquer market share through the deep introduction of metal additive series productions.
All right, and then I have brought one last customer voice from aerospace industry. So Brian, maybe you know Mr. Foubert. He's leading the AM activities at Safran. And yeah, he actually states it makes possible things that were not possible before. So as we have seen in some of the demonstrator applications that I showed you.
One of the reasons we believe strongly in the additive industry is that it makes possible things that were not possible before. And particularly, if I think about engine, we can think about configuration of engine that are not possible today with classic manufacturing processes. So why additive in manufacturing for us? Bringing new technology to the market to better have our product respect the challenge of moving the people safely, but respecting the planet. And second challenge is bringing down the cost. And so how Safran has decided to take this challenge, we have decided to launch a real serial production on aeronautical parts by building a new factory in Le Haillan. Challenge for Safran is building new type of parts and bringing productivity to our customer. For that, we need a plate that can allow us to bring new parts that were not achievable with current size of the machine, which is a first point. And second point, we need to have at the same time quality of the product plus productivity, and having an important number of laser plus powerful laser. It's a way that we definitely think it's the right way to be able to get the challenge we have a success. And for that, the machine looks like a good promise.
All right, that was the last voice of the customer about the NXG 12600 machine. And yeah, I come to my final slide actually. So I hope I was able to pick your attention on this new flagship, this new machine. And so, yeah, this is the process how you can assess the NXG 12600. So it maybe sounds a bit complicated here, but you can personally write me an email, give me a call. Yeah, you speak to our sales representatives, our salespeople in the US. Feel free to reach out to us. We are happy to give you a further product introduction if you're interested in purchasing one of these machines. We typically then support you in the business case and technical requirements. And then, yeah, walk our way through the customer journey until we have signed a final contract. So, and yeah, with this, I would like to end my presentation, my talk, and I'm open for more questions. Thank you very much.
Simon, thank you. And certainly, if you have a question, feel free to put that in the chat window now. I'd like to just share some of my experience, and for those joining us today and watching these on the webinars in the member portal later, you know, additive manufacturing it's such a big deal in aerospace, and I think we've only started to see the very tip of the iceberg when it comes to additive manufacturing. One of the things I feel is so important about this particular machine is not just that it's incredibly accurate and powerful and fast and efficient, and has a large build envelope that you can build large parts in. But the things that I keep touching on, and I think that this industry has yet to truly unlock the potential of this technology, is around what you can do with it. Simon showed us that electric motor housing there, and you saw it look like kind of like the veins of a leaf, but it was open in between it. I mean, just looked like tiny little pieces, thin pieces of metal. And what people don't realize is that there's software out there that can take the geometry of a big bulky part and create this structure that looks organic, that has incredible strength. And the importance for that in aerospace is you're able now to take very bulky, large parts like castings or large machined parts, and now create very lightweight organic structure. And it looks like something out of science fiction. And it doesn't visually look like it's going to be very strong, but it's mathematically calculated to create that incredible strength. So number one, massive weight reductions. In aerospace, that's incredibly important because that means that your airplanes get greater fuel economy. That's a huge game changer for folks with the parts being manufactured. Secondly, one of the things that Simon and I both touched on a couple times here, and I can't beat the drum loud enough on this one, is right now we take many parts and we screw them together, we bolt them together. There are gaskets, there are seals, there's a lot of tact time to assemble these larger assemblies. And for any given combination of parts, the more parts that you have combined, the more challenges you have. And that could be with tolerances, with the parts fitting. If you have gaskets and seals, if there's fluids inside there, those are places where the fluid can leak from. You have dissimilar metals, electrolysis that can happen that can create corrosion. And the list goes on and on and on and on. It's there's compounding factors of complexity when you're building up large assemblies. And what this technology can do, and why it's so important with this NXG 1200 or 12600, is you have a large build envelope. And so now for the first time, you can take an assembly the size of a dishwasher, and there's plenty of those on an airplane. And instead of having many, many parts that come together, you can actually build it essentially as one big part. And then with the software, you can take a tremendous amount of that weight out of there. So you're reducing takt time, you're improving the flow on the assembly line, you're reducing potential part failures and intolerances and leaks and corrosion and all these things. So for those of you that know a lot of folks in the industry, or you have some influence out there, I believe that we're entering a new era, and machines like this are going to help usher this in, where we are now going to transform the way that we think about designing parts for airplanes. But not only that, like we talked about with multiple metals being additive, you can create fluid passages within your part. So now you don't have a tube going through a part somehow that's being assembled. The tube is now part of the inside of the part. Throw some threadings on the end of that. Now you can have some fittings. And so now you don't have a whole bunch of parts, you have one part. And so this is an amazing advance for aerospace manufacturing. So Simon, do you have anything to add, or does anybody else have questions or things you'd like to add to?
Now, Brian, I can't explain it better than you. So it was a perfect statement for our technology, and everything was right and perfectly said from your end. So I really do not have much to add here. It's a fascinating technology. It's and now I think with the NXG 12600, we have come to the next stage, right? And now we have to get the designs ready for our machine. Yeah.
There you go. So Terry, I'm thinking about you specifically today. All the different companies that you interface with, you can kind of share about what the future looks like for aerospace there in Snohomish County in particular. Some really fascinating stuff.
Thank you, and Brian. And looking at just the complexity of that, it just reminded me of when I went to the air show, my first one, I was probably 4 or 5 years ago, and seeing these 3D printers, and I just marveled at the complexity of it, but it was nothing like what I just saw here.
Right.
This is fantastic. I just think the sky's the limit.
Yeah.
Amazing.
It sure is. Yeah, absolutely. So yeah, stay tuned. I was sharing with Simon before we're going to start to transition back to in-person events here, hopefully over the summer. And we've had a great partnership with SLM. And we're very proud to be a partner with SLM, especially after seeing some of the products like you saw here today. But we did an additive manufacturing event, a symposium at the University of Washington a couple years ago. And once we get back to in-person events, we know that we will have SLM out once again to an additive manufacturing symposium. It's not on the calendar. It probably won't happen this calendar year, but we will once again have them out here, and we'll be talking more about that. So Simon, first, thanks for joining us and staying up late to deliver your presentation. It's been a pleasure to have you on board. And once again, if you have questions for Simon, you can reach out to him or feel free to reach out to any of us at PNAA, and we'd be happy to facilitate a connection with him. As well as SLM does have a local rep here named Kevin, and Kevin's also another great resource who can show up to your facility even and talk with additive manufacturing with you. So great folks there at SLM. So thank you so much.
Thank you, Brian, for giving me the stage here. Was a great pleasure to talk to you all.
Absolutely. Thank you, Simon. Appreciate it. Just a quick reminder, we've got all kinds of events coming up left and right. Maybe take a screen capture. We talked about a few of them at the beginning of the event today. A couple other things we're going to have coming up. We are going to have June 8th, a webinar, Federal Sales Masterclass. We're going to have an expert coming in talking about doing business with the government. We're going to have some other things coming up here June 11th. SAP is going to be talking about a small business health monitoring dashboard that they put together with a company called Patriot, and we will be sharing how that can help your company. And AJAC Factory Friday coming up June 25th. July 8th, we'll be doing our first in-person networking event. That will be Summerfest. So check out our website for more information about that. And once again, we'd like to thank all of our different corporate circle sponsors. Terry, thank you for your support on behalf of Snohomish County, of course, and all the other different corporate circle sponsors. So keep an eye on our website, a lot going on. You can go to pnaa.net, hover over events, you'll see a little calendar. You can see all the different activities that we have coming up. We hope that you enjoyed our presentation today and learning quite literally about the most advanced additive manufacturing equipment in the world brought to us from SLM over there in Germany. So once again, thanks for joining us, everyone. We hope to see you at Women in Aerospace this Friday and at more upcoming PNAA events in the future. So thanks again, everyone. Appreciate it.
Thank you, Brian.
Thank you.
Thank you. Bye-bye. Enjoy your day in the US. Bye.
Thank you.
Thank you, everybody.
And go to bed now.
Okay.
Good night.
Good night, Simon.